So good evening, everybody. I'm Sandeep Kulkarni on behalf of German Corporation, GIZ, NHMC, and Dynamic Foundry Group. Welcome you all to this today's webinar on core shop process control. Uh, pros- as we all know that core shop is a very important aspect or important section in the foundry. Normally, we are using core for a critical section which is difficult to get in the molding, so criticality of shape, then where the surface finish uh, is required, importance of surface finish is there. In that area, normally we are using core. So quality of core must be good because it is basically required good surface finish as well as it is having some critical shape. So the quality of code is very important, and with that aspect, we are not looking at core shop as a management, as a process control, as a inspection, as a quality. We are neglecting this area to larger extent than other melting area and molding area. So today we are going to see some of the areas in core shop, some of the factors which if we can improve on, definitely our core quality will improve, the commerciality in the core shop will get improved, and of course our quality of overall casting quality will also get improved. So let us start with the presentation. First of all, always, most of my webinars say in Foundry there is no way to shortcuts. Avoid shortcuts because shortcuts will always give you uh, bad quality, always give you problems. So avoid shortcuts. So this is very important. In Foundry there is no space for shortcuts. It leads to you for a quality issues and rejections. So that we definitely have to avoid the shortcuts in the process control. Today what we are going to cover is core boxes and core box inspection, then sand control and sand mixing, then core making in cold box, no bake and shell core. Then we are going to see painting of cores. Then are going to see storage and identification and core transport and FIFO. Core shop costing we are not covering in this because time slack. We have been already doing some small videos on those core shop costing. But in about 7 points, definitely will be touching upon the importance of core costing. We are also going to see the one of the survey that we have conducted, the Dynamic Foundry Group have conducted last month on cold box core making all over India. So that's also we are going to see in during the presentation. So let's start with core box inspection. We all know that tooling is an important factor because we all know that input, process, and output is the importance of that. So the quality of your tooling will definitely reflect your casting as well as core. So core box inspection is very important, and I think this is one of the most neglected area in the foundry. We are not looking at core box inspection with that perspective or not with that care. The attention given to the core box inspection is very less. So this isn't going to be important factor. So we are going to see that particular activity in detail. Core box inspection includes doweling, then core box vents, then core box finish, use of stripping agent, then core box life, that is tool life, and keeping ready core box for the production before as per the planning, so that there should not be any hurry or any urgency coming up. So we'll start one by one. It is important to have good input quality to have good output quality in each stages. So we already talk about that. So to have good quality of core, one must have a good quality of core box available for the core making process. Hence, the inspection on cleaning of core boxes plays an important role here. And also, when you start production run, you have to do some preventive work to maintain the core box quality or core quality. Uh, Very important that once before we start the core box, we have to check the core box and make it proper for the production. But during the production run also, we have to take care of core box inspection, core box preventive measures, as well as checking the core quality continuously. So it will leads you to give a good quality of core. So checklist for core box inspection. So first is core box name and identification is important so that you can find it easily. There should not be a waste of time or wrong core box to be taken for the production. So this is important. Then core box finish is very important. Core box doweling is important. Core box handle or mounting of core box in case of automated core machine or core section. It is important. Then core box damage is important. Core box vents is important factor, and last but not least is core box parting line after core box closing. These are the most important checklist points which we need to check during our core box inspection process. We go one by one. Each and every core box must have identification available on the core box and also on the rack where the core box is kept. This will help the person to get right core box at right time and with minimum search time. So we avoid searching of core box. We avoid wrong core box being put on the production for to avoid such incidents. So you must have a name on core box as well as in the rack so that person can easily go and find out the core box, which core box he has to put. Secondly, most important thing is core box finish. Core box finish is important factor again. Core box finish depends on the core finish depends on the core box finish. So maintaining core box finish is important. Before start of core making, every time one has to clean the core box to maintain the core. So it is very important that you have to keep your core box clean all the time to maintain core box surface finish good. Thirdly, Mr. Navile, I think you need to mute yourself. You are unmuted yourself. Mr. Navle,
My company.
you have to mute yourself. Yeah, thank you. Use Corebox cleaning agent for the cleaning of Corebox. So you have to use cleaning agent for the cleaning of Corebox. This is important. Apply it with the brush and then clean the Corebox. So I have put up some photographs also how to clean the Corebox. You can see you can just apply that agent, that is cleaning agent or releasing agent on the core box, and then you can with the brush and then you can uh, wash it or you can clean it with the good quality of cloth. And there are some areas where you can see some foreign particles been deposited. You can clean it with the you can say knife or blade, and then again put some releasing agent, clean the core box with a good cloth so as you can get a good quality of core box finish. You can see here a bad quality of core box finish, and then you have seen the good quality of better quality of core box finish. So if this about the quality of core box you use, then you will get some scratches on the core. Some core finish will not be that good, and if you clean that core box properly and use it, then you will get definitely a good surface finish for your core, and definitely your casting will be good. So rework of core, rework of casting will get eliminated. So this is very important. So you take care of your core box finish, you have to reduce your fettling. Your fettling cost will get reduced because of good quality of core and good quality of casting, because of good quality of surface finish of your core and core box. Next important thing is doweling. Core box doweling is one of the important factor and neglected area as well in the core box inspection. Most of the time we do not give much importance to this area, and this area is in the mismatch of core, plays an important role in mismatch of cores, dimension accuracies and of the course. So we are giving more importance to pin molding, pin bush inspection, molding gauges, or you can say closing pins, but we're not giving much importance to this core box doweling. Most of the time the dowels are being not checked regularly, and dowels are getting worn out. It is getting the dowel holes are getting worn out and dowel pins are getting eroded, and because of that you find the core box are mismatched and your cores are also coming mismatched. It gives you a problem of wall variation, dimension inaccuracy and all these things. So you can see the photographs I have shown you, some of the eroded, how the worn out holes are there, how the wall eroded dowel pins are there. So whenever you are checking the or inspecting the core box, you have to give proper focus on this area as well. You have to see that you have to change those dowel pins, and you have to change those dowel hole bushes on periodic basis. You have to make such a plan for that, for inspection and for changing, so that you will not find this kind of controversies or this kind of inaccuracies in the core in during the production run. So this is another example where you can see the dowel pins are properly made, the dowel holes are properly made, so we're not having any issues with such kind of tooling. Next important thing is core box handle. Core box handle needs to be checked before you take core box for the production. It is having also safety issue, because if the handle is loose and during the handling, if the handle gets out from the you can say nut bolting or something like that, then there is a chances of accident also. So it is a safety precaution as well. So you have to check your handle properly. In case of automation, you have to see that the core box half are properly mounted on the walls of the core boxes, and they are matching each other very well. So all these things has to be taken care during the core box inspection. Check core box for the damage. This is a very serious matter, and I think most of the foundries, most of the areas, I think we are having these kind of issues happening all the way, that core boxes are damaged, and because of damaged core boxes, there are huge leakages of amine. There is huge leakage of sand. The core dimensions are getting increased, and all these things are happening because of core box is damaged. So check core box for the damage. One has to keep core box properly in rack to avoid damages and handle them with care. So this damage is one area where this damages happen because of handling of the core box. The second important handling is as core box is integral part of tooling, and without core and core box one cannot run the production. The importance must be given to core box storage as well. So we are giving very good importance or very good response to our pattern storage, but core box storage we are neglecting. But one has to understand that even pattern is available, everything is available. If core box is damaged or core box is not available, we cannot able to run the production. So so we have to give similar kind of treatment to core boxes storage and core box inspection also. So storage of core box is very important. You have to give proper attention to that, so that you will not lose your production. This is one side we have talked, that is the damage during the storage and handling. Other type of damage is because of when we are releasing the core, we have to sometimes have use hammer, and during this activity, people are using metallic hammers or ferrous hammers or cast iron hammers or steel hammers. So it is very dangerous thing, because it will damage your core box heavily, particularly the corners of the core box. And whenever you close the core box, there will be some gap at the corner, which will allow the sand and amine to flow outside the core box, and it will not give you good finish of the core box. It will give a lot of smell of amine outside. It will increase your amine consumption. It will increase your sand consumption, and all these things will happen, and it will definitely cause you a bad quality of core. So you have to take care while ejecting the cores, as a metallic hammer not to be used, only use wooden hammers to avoid damages of core box. So this is very important factor, one has to remember it and percolate it to the shop floor, that wooden hammer should be always preferred. uh, First of all, if you have an ejection system, there should not be any reason or any hammer is required. But even though some hammers are required, then you have to use wooden hammer, not metallic hammer. This will give rise to leakage of sand through gap across the parting line. So because of these damages, it will give you a leakage of sand through the parting through the gap where the parting at the parting line where those damage are already created. You can see some of the photographs for the damages, how these damages are there, and how they will affect your core quality badly. So this is one of the example of core box with damage. This mainly happen in shell core because shell core people are using not using wooden hammer because core box is hot and a hot condition they are avoiding wooden hammer and they are trying for the metallic hammer. There you have to really work hard to get proper draft angles and everything so that your core will not stuck inside the core box. It will easily get removed and even wooden hammer can work there. So it is very important factor. One has to understand the importance of this uh, damages of the core box and work accordingly. Next important thing is loose pieces. There are many times in core boxes there are loose pieces required, and similarly one has to take care of loose pieces, need to keep them safely as it look loose in nature and small in size. There are always chances that they can get misplaced, and for the production will not get them in time, or we lose it, then you have to go for another loose piece. We have to take trials and all these things. So you have to keep them in a safe areas, in a safe control, so that a person can get it easily whenever he requires. So separate system must be done for the storage of loose pieces for the pattern as well as core box both with the proper identification. Next point, important point is one has to check whether core box has enough vents and are in good condition or not. So this is important factor again, that your core box must have proper venting system available and the vents are in good condition. Vents are provided in the core box to pass out the air which is shooting while shooting. It helps in filling the cores properly, particularly in the we can say thin area or in critical passages there where the shooting is difficult. You have to have good venting requirement is there, particularly deep down areas and critical areas as well. So importance of air venting and cleaning it regularly in the core boxes is very high. Some of the snaps are provided for in the slide for future slide for vent cleaning. So how to do the vent cleaning? These are the pictures for the brass vents which we are talking about. This is one of the core box in our foundry where the we can see lot of air vents are provided so that critical cores can be easily produced. So this is very important. The design of where to provide the vents, how to provide the vents, how many vents to be provided. All these things are very important to get good quality of core. That is surface finish of good quality of surface finish core. And this is how the vents can be cleaned with the proper blade. You have to sharpen the blade. Full extra blade is not used, it will damage your vents. So you have to properly sharpen it and then use that blade or even sharpening tool for cleaning the vents. Check the clearance at parting line by closing the both of the cores. It should be zero. What I was talking earlier also, that your parting line should be 0 0. There should not be any gap in between two halves of the core. If the gap is there, the sand will go out, amine will go out, it will affect your core quality. So it is very important to have both core boxes closed with zero tolerance. If there is any gap in the parting line, it will increase the core dimension across the parting line. Core weight will get increased, and also due to that, sand coming out from this gap, core filling will not good to get bad cores. Core closing must be one of the important point of inspection of core boxes. So before you start the production of core, you have to close the tap and verify the gap is
ये
there.
वकील साहब का जो है माइक क्लियर है
Shashank,
जो
you
लाइक
are
है सर
Shashank,
5,000 रुपये इसमें एडवांस कर देना Hello.
Shashank, you have to mute yourself.
Yes, yeah.
Similarly, tightening of clamps is also important. Sometimes we have to use clamps for joining the core boxes. So if clamping is not proper, it is loose, then definitely there will be some gap and your core dimension will get increased across the parting line, and it will also hamper your quality of core, and dimension accuracy will not be there. So it is very important. So also avoid hampering of core box surface. It may cause an uneven surface at parting line, and it may cause for a sand leakage. through the gap and core quality gets bad. So this is what we are talking about, the closing of core boxes. You can see here a gap is there at the right hand side of me and also on the left hand side also. And when the clamp is done properly, the gap has been totally removed. So you have to verify these small points in your core box inspection before you start the production, so that whatever quality you produce in the core shop will be having good dimension, good accuracy, good surface finish, and it will avoid further damages. So preventive checkpoints after every one, after every core, one has to clean the core box with air. This is also important because some sand grains are sticking with the core box, so you have to clean it with the air with every shot, so that your core box remain clean and clean for the next shot. Then after every 1 hour, one has to clean air vents with the blade. Every 4 hours, one has to clean the core box with cleaning agent. So this is also important, that every 4 hours you have to clean it with the cleaning agent, so that whatever some deposition will be there on the core box, it will get released. Make first piece inspection after every new production run. I think this is where we also lagging. A lot of foundries are lagging because we are doing first box inspection or metal inspection or first piece inspection at the casting level, but core level we are missing it. So we have to start it immediately, so that we at least we can measure some important parameters of the core dimension, scratch hardness, and even I will show you some slides in the end as well. The cut section of the core to see the curing, proper curing of the core, etc. So that we can get that idea that whatever core production we are going to get is of good quality. So this is a preventive measure, we can say. Core box scanning and PDR for dimension to check wear out must be done every 6 months or 1 year, depending on your volumes. So like a pattern inspection, we have to do core box inspection, dimension, PDR also for important parameters once in a 6 month or once in a year, depending on your volume of core making or casting making, so that you will not able to see a problem coming out from your customer end, that there is a major issue with the dimension at the customer end. You can able to find out at your end that yes, my core box is getting worn out, I have to go for new core box, I have to plan it for core box for the next 3 months or 6 months. So this is very important as a preventive measure, one has to look at this way. So this is a small table I have made for the preventive checkpoints in the core box inspection. Core box cleaning before start of production is important, and every 4 hours it is important. Core box cleaning with air after every core, it is important. Then the core box air vent cleaning is important every hour. We have to clean the vent of the core boxes. First piece inspection, initial 5 samples, and dimension inspection of the core periodically every 6 months or 1 year. So if you make this kind of table or a chart as per your own norms in the core shop and put it in the core shop, then definitely your person, your core shop pupil will follow it, and you will have a good quality of core box, because core box as well as cores, because of good quality of inspection. So your inspection of core boxes will improve. So this is one of the stage of we can say input material or input for to your core making. So if that is improved, definitely your output of the core making will get improved. So we now move to tool life. That is the second part of our presentation, is tool life. So we all know that tool life depends on the material, which material we use for the making of the core box. Just like aluminum, we got around 40,000 blows. CI, we got around 75 to 75,000 blows. Treated steel, we got around 1 lakh blow, and PU material got around 1.25 lakhs blow. So as per this slide as I've taken from Mr. Avinash Joshi's presentation during our core box panel discussion, as per him also, that PU material is good. Only thing we have to check the construction of core box, whether you can able to construct the core box in PU properly, stability of cores and sand sticking, etc. All these things. If it is happening good, then PU is a good material. But normally people are going for aluminum and CI. Aluminum, the reason is simple, it is lightweight, easy to handle. The movement of core box can be faster. the core making activity can be speed up because of the lightweight of core box. So the aluminum is preferred, and cast iron where the volumes are higher. Those core boxes which are been mounted on the core box machines for the automation. Normally, people are going for cast iron core box because it's only one time handling of the core for lifting it with the we can say stacker and putting it on the wall of the machine. There's only one time activity is there. Then they don't have to handle the core box manually. So in that cases where automation is there, volumes are more, cast iron core boxes are more preferred. Where the handling is manual, people are going for the aluminum core boxes. Next point is core making processes. We are going to see one by one. Uh, I I think we'll finish this and then we'll break for. So we'll start with the core box processes. The first process will core box. Clay content must be minimum less than 1%. So whatever sand we are using for coal box, clay content must be less than 1%. Sand AFS is 55 to 65. Normally people are using to get good surface finish of core. Dry sand is important. You have to have a dry sand. Dry sand will reduce your resin percentage consumption. Normally people are using A part 0.8 to 1.2%, B part 0.8 to 1.2%, amine 0.2 to 0.4%, and scratch hardness above 60 is preferred in the coal box. There are some we can say survey reports which are available with us. We'll sharing it later on with you. So coal box scratch hardness, you can see the scratch hardness been checked. In this case, we are finding it around 80. Above anything, above 60 is preferred to be good. Below 60, you have less strength of the core, and there are chances that dimension accuracy or will not get good surface finish as well. So required scratch hardness is 60 and above. Then we go to Novec. Novec is basically a two-part Novec we are talking mostly here. AFS required is 50 to 60. Clay content, as always, less than 1%. The less is the clay, your resin consumption will be low, your scratch hardness will be good. Use again dry sand here. A part should be 1.5 to 2%, B part 1 to 2%. Again, it depends on the climate conditions. In the summer, you will get require less quantity of A part and B part. In the winter section and in the rainy season, you need more amount of B part because of the climate condition. Stripping time and setting time depends also on the climate condition as A part and B part also. Setting time and parting and B part will change as per season as I told you, and the scratch hardness is again above 60. Then we go to shell core. Shell core, here the clay content must be minimum 1% again. Here the sand AFS is higher, 60 to 75 to get good surface finish because most of the people are using shell core for to have better surface finish. So your sand AFS is always higher on a higher side. Resin normally uses phenol formaldehyde resin to be used 2.5 to 4.5% is the normal range which people are using. Then it it is a hot process as we all know. Baking of core till biscuit color is important. This is very important factor. Do not use over baked or under baked cores. I have shown some of the photographs for your ready reference in future slides. This is how the importance of resin. 2.5% resin will give strength of 12 to 17. 3% will give around 7 to 20. 3.5% will give around 20 to 22. 4% will give around 22 to 26, and 4.5% will give around 26 to 32. So you have to use resin percentage based on what strength you want, what type of core you want to make. So it depends on that particularly. But as resin increases, gas also got increases. Remind it so that use optimum percentage of resin. Do not go for higher resin. the cost will go increase, your gas will go increase, and definitely you need to have more precaution in the molding if your resin percentage is high. So try to optimize your resin percentage. In shell, it is important to have temperature of core box is important because it is a hot process. At what temperature your core box is there is important. Heating temperature normally is 250 to 400 degree. Heating or curing time is also important, depends on the core box size and temperature and heating zone. Ensure uniform heating temperature all the side of the cores to get equally baked core. Sometimes you're using some coils. One of the area coils are not working properly. Some of the area coils are good. Then one area heat temperature will be more, other area temperature will be less. So baking will be uneven. So you have to keep that proper care to ensure the uniform temperature all the side of the core box to get equally baked core. Hot strength of the core is important. You have to measure it. Scratch hardness of the core. Cut section of the core is ensured to proper baking of core. And most importantly, biscuit color is most desirable. So I've shown you some of the unbaked core. First core is unbaked core where you can see a yellowish color core. It is not properly baked. It is underbaked. You can see the OK core, the down where the you can see a biscuit color is there, and this is overbaked core, which is almost brownish color, which is already overbaked. So this core will give you erosion of the sand. So you have to avoid this underbaked or overbaked core. Here I have cut down the some of the cores. You can see one core, the heavy section is there. The sand in between the core is not uh, baked properly. You can see the sand is still there, so baking is not uniform in first core. Second core, you can see the baking is quite uniform. So this you have to check when you are going for the particularly thick section of cores. You have to cut down the cores and verify that the baking is uniform all over and you are getting good quality of core. So it is a scratch hardness. Again, you are seeing it around 80. So these are the some of the reports which are we are going to see. We'll do one thing. We'll stop here and we'll join immediately with the same login password and ID for the remaining presentation. So kindly join again within the 2 minutes.